Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. You would have noted that we have already concluded our work on mapping skills, but be mindful and be reminded that mapping skills are very important skills that we have covered, and we are going to actually do a lot of work on skills throughout the year, and we must make sure we remember what we have already gone through or learned together. What we have actually done for mapping skills are basic, and then later on we'll develop those when we do more practice, if we are maybe given skills work to actually do together in class. We are going to move on now to our content work, and each one of you should have a booklet, and that booklet will give you an idea on the topic that we are going to actually be looking at. And the topic is an introduction to physical geography. What is actually in store for us in this book? We are going to look at the objectives that you will find now on the first page or page 1 of your booklet. By the end, or at the end, when we complete this booklet, these are some of the objectives that we would like you to be able to achieve. Number 1, you should be able to identify the Earth's sphere. Explain what tectonic plates are. Name the major plates. Explain plate movement. Describe the geological features created by plate movement. Describe the balance between the constructive and destructive processes of the Earth. Distinguish between erosion and weathering. Describe the 3 types of weathering. Explain what deposition is. Explain how volcanoes are formed. Describe the distribution of active and extinct volcanoes in Papua New Guinea. And also describe the effect volcanoes have on people's lives. So if we look at all of those objectives that we are going to cover from this booklet, most of them are to do with physical geography. And when we study or when we look at our work on physical geography, it will be based mainly on the Earth's formation of the Earth, and the many features which are formed as a result of plate movements or tectonic plate movements, that is. Those are the objectives that we would like you to be able to achieve once we complete this booklet. Okay, looking at those objectives now, we are going to move on. Today, we are not going to look at any one of those objectives because I'd like to maybe go through an introduction, and the introduction is simply to familiarize ourselves with what is going to be covered in our booklet, and not only that, to look at what we call the importance of understanding time span, or the amount of time it will take for creation of the many features, the physical features that is, that we find on the surface. And to maybe appreciate a little bit about the time span I am referring to, we are going to look at what we call the geological time scale. Before we go to that information on the monitor on the geological time scale, I'd like to read a reading here, of which at the end, I would like you to think about what point is this particular reading trying to make. So in your minds now, you will be telling yourself, what is the point behind this reading? Okay, the reading here is titled, A Sense of Time. It is adapted from The Restless Earth by Nigel Calder, which is a BBC publication. Okay, I'll have your ears and you'll listen. The title again, A Sense of Time. 10 years is a long time in modern science, and a long time in the life of an individual. So you can go back, imagine 10 years. 10 years ago, where would you have been? What would you have been doing? It's a long time in the life of an individual. It's also a long time in modern science. But to our planet, 10 years is almost nothing. It allows time for a few volcanoes to erupt and for the release of a multitude of earthquakes, but not for the continents to shift by more than a few centimeters. Very few, if any, people will notice the change in their lifetime. Given time, hard rock flows like pitch. Given time, the continents where you sit could split, open up, and allow a new ocean to form. Given time, another continent might collide with yours and push you up above the snow line. Such things are common in what we call geological time, but we certainly will not see them as they take millions of years. A million years is difficult to imagine, but the Earth is reckoned to be 4,600 million years old. So we're looking at 4,600 million years old. That's how old the Earth is reckoned to be. If we imagine perhaps the Earth has been 46 years old and not 4,600 million years old. Okay, we are going to imagine now that instead of the Earth being 4,600 million years old, let's imagine the Earth has been 46 years old. You could imagine 46, right? It's within our lifetime, our lifespan that is. And it's easy also for us to count up to 46, of which all of us could do that. But how about 4,600 million? Could you count up to 4,600 million? Okay, so let's use 46 years old. The Earth, we imagine it now being 46 years old and not 4,600 million years old. There was no life on Earth at all until the Earth was 42 years old. So between when the Earth was born, 0, up until 42 years, there was no life at all on Earth. Until 42 years old, then there were evidence of life to be found on Earth. And flowering plants, they only appeared last year. Dinosaurs, they disappeared 8 months ago. A couple of days ago, the Earth was shivering because of the ice ages. And just 4 hours ago, the first humans appeared. 15 minutes ago, Moses led the Israelites out of Egypt. And 1 minute ago, the Industrial Revolution began. And it's only a few seconds since the Second World War. All of this is simply trying to illustrate the fact that when we are looking at geology and the way in which the Earth has developed, the length of time involved is enormous. And that's what the reading is actually trying to make. Very few changes will actually take place quickly. And those few changes could be changes such as earthquake, volcanic eruptions, and perhaps flooding, tidal waves, and so forth. But in terms of the general buildup of the Earth, it has taken millions of years for the many features that we have today to have occurred and to also change. So let's look at that particular reading now, and let's look at the geological timescale showing some of those main events which have occurred and the amount of time or the time span which has actually been involved for those particular events to occur. So if we look at that information on our monitor, the time scale itself is divided into 3 columns. The first column shows us the era. The second columns, they represent the period or system, and the epoch or the series. That's for the second column. And the third column shows us the time which is actually involved in the formation of those different events and also landform features that we are going to study about in our work on physical geography. Okay, so we'll start from when the Earth was actually formed, which we just read and found out that it would be about 4,000 to 6,000 million years ago. Okay, some of the things that we've looked at would be things like dinosaurs. Dinosaurs would come in together with the period of time of which, or the period or system of which we could say Jurassic. You've heard about the Jurassic period? Okay, maybe a movie was made also, the Jurassic Park that is, and it showed information about dinosaurs and all those different animals that lived during that time. So if we're looking at about 180 million years ago, that would be when those animals or mammals were actually living, dinosaurs that were. They became extinct about, say, maybe 65 million years ago, those mammals became extinct. But for them to have lived, they would have lived about 180 million years ago. That's a long time in terms of geological time scale. Perhaps another important information that we have already studied maybe in grade 10 would be that of the Carboniferous period. This is basically looking at about 350 to 360 million years ago when coal deposits were actually formed throughout certain parts of the world. And those deposits, of which some of them are used today for extracting or mining and taking and using in areas or industries where it is needed. But we are generally looking at a geological time scale, of which the time scale gives us the amount of time in millions of years that those different events would have taken place, and of which mountain building, landform features would have also come in together with those different events that occurred during that time. Any questions so far on what we have looked at on our introduction to our work on an introduction to physical geography? No questions? Okay, if there are no questions, then we will move on. We'll move on now to looking at the information that is presented from our booklet. And we're going to look at page 2. The information from our booklet now gives us an idea about our planet Earth and also the zoning of the main elements within our planet Earth. So let's look at the information from the book, and we'll go through that together so that you can be able to complete the 2 exercises which are given at the bottom of that page. The Earth. Since the beginning of time, people have had their ideas about how the Earth was created. But scientists nowadays, they believe that the Earth appeared about 4,600 million years ago. The scientists, believe that at that time, another star passed close to the sun, and the gravitational pull of that star pulled a ball of burning gases away from the sun. Ever since then, the gases have been cooling, and some have condensed to form liquids. Some oxygen and nitrogen have remained as gases in the atmosphere today. After further cooling, the liquid materials near the Earth's surface solidified to form the outer crust. Similarly, for hundreds of years, scientists have observed the shape of the Earth and tried to explain what they see: the mountains, the valleys, and so on. But until very recently, no single theory was able to explain satisfactorily most of these features, but over the last 25 years or so, more and more evidence has supported the idea known as plate tectonics. Scientists had known for a long time that the Earth consisted of different layers and that the Earth's crust was a very thin layer floating on a denser liquid rock beneath. But what was missing was an explanation of the actual shape of the crust and the movements that take place. Okay, with that introduction, let's go on to the information which is presented there on the monitor. And that information further talks about the evolution of the Earth. And here it says, at a time very early in its history, that is the Earth's history, the Earth was mostly molten sphere. The forces of the Earth's gravity field acting towards the center of the sphere caused differentiation, with the heavier elements such as iron moving towards the center of the Earth, and the lighter elements such as hydrogen and oxygen, aluminum and silicon moving to the outer surface of the Earth. And in this way, a layering was actually developed from an iron-rich core to magnesium and silica-rich mantle to a thin outer shell or crust which is rich in the lighter elements. We come now to looking at the diagram which is given in our exercise book. Sorry, not exercise book, but from our booklet, as well as the diagram on our monitor there. So when we look at the Earth generally, we can say that the Earth can actually be considered into 4 main zones. And the 4 main zones are the atmosphere, the hydrosphere, the lithosphere, and the biosphere. If you look at the information from your booklet, that information is also presented in your booklet, showing the cross-section of the Earth and the 4 main zones that the Earth and all the elements on Earth can be divided into. What I would like you to do now is, using that information from the monitor and also from your workbook, I'd like you to complete exercise A. And for the first exercise, it is very simple, so that should take you less than 5 minutes for you to complete, putting in those different spheres or zones and then finding out what each of those zones are supposed to represent. I think perhaps 3 minutes is plenty of time for you to be able to complete at least exercise 1. The information into your exercise book. You put your title, an introduction to physical geography, exercise 1. Okay, we're going to correct at least exercise 1 or activity 1. You're supposed to study the information given from your book, or you could look at the information given on the monitor, and you would have realized that there are 4 main zones or areas within our planet Earth, of which all other elements can actually be put under. And those different spheres are: the first one given atmosphere, the second one lithosphere, the third one hydrosphere, and the last one biosphere. So you are now asked to explain what each of those spheres are a zone of. We'll start off with Val. Val, can you tell us your answer for the first question on atmosphere? What is atmosphere the zone of?
Atmosphere is the zone of air.
Okay, good. We're looking at the zone of air. So for our study with that information on the atmosphere, when we move on to the second booklet, which is on climate, that is when we are going to look at the atmosphere in a little bit more detail, because it is with the atmosphere that climate can actually be explained. So with the atmosphere, later on, we will look at the layers of the atmosphere, that is the troposphere, the stratosphere, and the ionosphere. And we will also look at how elements within the atmosphere can contribute to formation of features such as rainfall, clouds, and so forth. And that will come in term 2, or in the middle, or not beginning, but middle of term 2 when we complete this booklet. Okay, so one of the important spheres that we find on our planet Earth is the zone of air, and that is the atmosphere. The next sphere, which is the lithosphere, Moses. What is the lithosphere the zone of?
Lithosphere, the zone of rock.
Okay, we're looking at the zone of rocks. Thank you. It is this particular sphere that we are going to concentrate on mainly with our study when we are looking at this booklet, because the booklet here will contain information mainly on the lithosphere. So when we talk about the lithosphere, we are basically looking at the zone of rocks. Hydrosphere. What is hydrosphere the zone of? Silo, your answer for hydrosphere.
Hydrosphere is the zone of water.
Okay, good. Hydrosphere, hydro, water. So hydrosphere is simply the zone of water. And when we look at that information again, that's when we look at climate. And as well as that, when we look at our case study on rivers, we are going to cover a lot of things on water. So zone of water is the hydrosphere. And finally, biosphere. Biosphere. Dorothy, your answer for biosphere. What is that the zone of?
Biosphere is the zone of life.
Okay, good. It's simply the zone of life. Bio, life, as in biology. Okay, note for that particular sphere, that is when we are going to do a lot more work on vegetation. When we work on climate and when we look at vegetation, that's where that particular sphere will be looked at. Okay, so here goes. What we have completed is a table of which that contains some of the important spheres, or the 4 important spheres of our planet Earth, and the main elements which are found within those different spheres. We'll move on. The next activity that I would like you to work on. If you can recall, from the start of the lesson, I went through some readings, and those readings, they contain information generally on how the Earth was formed. Using the information now from your booklet, and the information from, perhaps the very brief information from the evolution of the Earth from the monitor, what I'd like you to work on now is to explain in your own words, scientifically. I am adding that one word, scientifically, how it is believed that the Earth was formed. And the reason for why I am adding the word scientifically is so that you don't take the easy way out and say the earth was formed by God, which is definitely true, and then full stop, and you don't have any explanations further. So therefore, I am going to add in one more word in there to make you research and find information on how you think or how the earth was believed to have been formed scientifically. Okay, that is your task, and I'd like you to collect now or do your brainstorming now and come up with maybe your notes of which you will put together for your homework, and you'll have your paragraphs completed, and then tomorrow in our lesson you will be required to read and explain to the class what you have researched or what you have put together. So I will put up the question again. The question is to explain in your own words scientifically how it is believed that the earth was formed. So for the lesson, you are simply brainstorming your information, putting them together. Your homework now will be to write out in a paragraph or in paragraph forms to explain how you think the earth was formed scientifically. Which means the booklet that you have is not enough. You will have to look at other information to come up with your explanation. And be prepared tomorrow in class if the students ask you to explain a little bit further. So that means you must do your research well and be prepared to give our answers tomorrow. Okay, we have about 5 minutes to the bell, and for the 5 minutes, I would like you to start on with that activity. Okay. Okay, maybe to conclude our lesson for today, I'll summarize what we have done so far. And then your homework is to ensure that you have your paragraphs ready to present tomorrow in class. Okay, looking at what we have done so far, we've started off by looking at the booklet, what is actually in store for us, by looking at the objectives. I also went through the information on generally the Earth and how the Earth was formed. We looked at the 4 main spheres, which is the atmosphere, lithosphere, hydrosphere, and biosphere. And I also mentioned that when we are studying or when we are looking at the work on this booklet, Introduction to Physical Geography, it is important that we look at or we appreciate the amount of time it has taken for the many features that we are going to study about to have occurred. And the geological time scale that I went through with you very quickly was an example of the amount of time or the enormous amount of time that has been taken for the formation of the many features on our planet Earth, as well as the changes to those many features on our planet Earth. And that's what we have basically looked at today. That will also conclude our lesson. So class, if you can now stand up. To the pilot teachers, our keyword for today is sphere. That's for lesson 18. Good afternoon, and thank you, class.